So this is going to be, we're going to have net ionic. All right, let me just see. So we're going to have complete ionic. We're going to write that over here, and then we're going to have net ionic over here. So what that basically means is, whoops, I'm going to draw these two lines for where we want it. So complete ionic is that we basically write these as ions. Or we'll probably use the salt example. So you know salt is NaCl, it's a solid. When you add it into a water, it becomes NaCl aqueous, which means you basically dissolved it into the water. But technically this isn't quite right because when salt is dissolved, it dissolutes, which means that it separates. So it separates into sodium ions and then chlorine ions.
Yeah.
So they break apart and stuff is floating around. The complete ionic equation basically just shows that. So we would have silver nitrate, and then you'd have to make sure to say that it's aqueous. Plus, well, we have the silver plus the nitrate, aqueous. So you can see that first one split up like this.
Yes.
And you have to do the same thing for the salt as well. Anything that undergoes this splitting apart, anything that's soluble, you're going to have to split up in your complete ionic. Aqueous, and the chlorine, also aqueous.
So aqueous means it's soluble?
Actually, aqueous technically means that it's already dissolved.
Okay.
Yeah. Do you know your solubility rules?
No.
Oh, okay. That's all right. Well, I'll basically just show them to you.
Yeah, I wrote it down on my notes. So.
Yeah, let me just quickly grab an image, solubility rules. It's just a big chart you're going to have to memorize or just keep in mind when you're doing this. All right. This one's probably good enough. Okay. So looking at this chart, oops. Ooh. Sorry, let me just delete this. You just have to follow this to know what is soluble and what isn't. So starting over here, AgNO3. If we look, nitrates are always soluble. Basically, if it has nitrate in it, it's going to be soluble because these solutions are soluble and the exceptions are none. So that's why we know this is soluble. So we'll say this is, I'll just say it's soluble. But the same idea, if we go down to over here, this has sodium. Sodium is part of group 1, and that means that group 1 is always soluble as well. So your sodium, potassium, rubidium, any of those are always soluble. So because of that, this whole thing is soluble. Whoops. However, once we get to this one, you can see that it turns into a solid. And this is because when we have chlorine, it's always soluble, except when it's paired with silver, mercury, or lead. So because we have chlorine with silver, it is no longer soluble. which means that instead of floating around as its ions, it would precipitate out of the reaction. So this is solid.
Mm.
It's incapable of like splitting apart, which means it has to be together.
Mm.
And then if we look over here, sodium is always soluble and nitrate is always soluble. So this one's definitely soluble. So back to this one, that's what we basically showed here. We showed that these two are soluble.
Mm.
And because they're soluble, they split apart into their individual ions. Now, when we get to our solid, this doesn't actually split apart. So what you have to do is you have to write it as it's solid. You can't split it apart into its ions because that's not what it does in the water. And then you just finish it by doing, whoops, that's the wrong color. By doing the rest. So we have sodium with its charge, its aqueous, plus nitrate with its charge and its aqueous. So this is the complete ionic equation.
Mm.
Anything that splits apart, we split apart. Anything that doesn't, we just keep it the same.
Oh.
Okay, so to go from here to here, what you basically have to do is just cancel out spectator ions.
Mm.
And spectator ions are the things that are on both the left and right side. So let me just, oh, no wonder. Where did I put it? Okay, going to have to use this. All right. So spectator ions are the things that remain the same on both the left and the right side. So if you see over here, you have silver. This one's an ion, but this one's a solid. So we leave that alone. We go to our nitrate. There's a nitrate here and a nitrate here.
Mm-hmm.
So we can cross that out. The sodium's the same. And the chlorine we can't cross out because that makes it into,
Solid.
makes it into the solid. So the net ionic is what happens after we cross out everything, which is simply Ag plus plus Cl minus aqueous turns into silver chloride solid. So this is the net ionic. It's basically only the stuff that changes. Does that make sense?
Yeah. So net ionic, can it be liquid as well?
Can it be liquid? That's an interesting question. Can it be liquid?
So the net ionic is anything that it changes
Mm,
up to it?
to answer your question, generally that liquid isn't really possible.
Oh, okay.
Yeah, because you're forming net ionic equations basically means you start with ions.
Oh.
And since you have ions, there is no ionic liquid, which
Oh.
means you'll get to this when you learn intermolecular forces, but basically ions
Uh-huh.
are made out of one thing that's positive and one thing that's negative. And
Mm.
then they attract each other like magnets. this bond is so strong that ionics are always solids or dissolved.
Okay.
There are no liquid ionics, at least not at room temperature.
Oh.
Hmm.
How about the neutralization?
What was that?
Neutralization?
Neutralization? Oh, okay. Let me just stop.